Hi, everybody. My name is Andrew Gross. I am the technical manager here at Dassault System Solidworks, and I'm really excited to show you guys today something that I really love, which is called the Ambiguous Cylinder. It is an optical illusion that when I first saw it, it kind of blew my mind and got really stoked on it, and I have this great opportunity to show it to you. So this is the 11th installment of the SolidWorks live design series, which I was lucky enough to be a part of. And I'm following in the footsteps of some of the greatest. We had Mark Schneider and Jeremy Rigneris, Brian Zayas. We had some new folks like Michael Steves show some really great stuff. So again, I was lucky enough to be part of this. I'm really happy to show you guys some cool things. So one of the first things I want to tell you is where I'm from. So I live here in Los Angeles, California. It's actually a very beautiful day, nice and sunny day. I'm also very happy to tell you that today's presentation is powered by my solar panels on my roof, which I'm also very excited about. So where exactly do I live? So I'm going to copy one of my colleagues, Juan Chapa, who had a really cool live design session last week building a pergola at his house. Super cool. Well, I'm going to steal his great idea of using Google Earth, which is really fun. So I live in a little spot called Eagle Rock, California, which is about 5 miles north of downtown LA. Oh, look at that. It has a little blurb about Eagle Rock as an eclectic neighborhood. Okay. So this is where I live here in Los Angeles, California. Got some really cool stuff nearby. Right between Glendale and Pasadena. If you go a little bit north, the really cool JPL is right up there. A cool place to visit. And also Walt Disney Imagineering is just on the other side of the freeway from me. So that's pretty cool. So now that you know just a little bit about me, well, you also probably can see that I like bicycles. So maybe I could see from the chat, where are you guys coming from? I see that Gvidas is coming from Lithuania. That's pretty cool. Where else are you guys streaming in from? Love to know where you guys are at. Okay. So as I kind of see some of the chats roll through. Cool. All right. I see that folks, wow, lots of people. Bangalore. All right. Thank you, Prahaf, for coming in from Bangalore. So like I mentioned a moment ago, we're just going to kind of cancel out of this. Okay. So I really love what I'm going to show you today. It's called the Ambiguous Cylinder, and hopefully in a few moments you'll kind of see why it's so ambiguous. So, as a kid, I always loved magic. I think most kids do love magic. I see people are coming in. All right, some folks coming in from Mexico. Barry Harridge from the UK. Mahir coming in from Turkey. Really cool. Hi, Barathwaj. You're coming in from India. Mauritius. Wow. Hey, Irvine, California. MC88DX. Well, you're just right down the street from me. Pretty cool. All right, South Carolina. Welcome, Zachary. I see a lot of folks coming in. So, as a kid, I loved magic, but what I loved more than magic was I loved optical illusions, and that's what I'm going to show you today. So, let's talk a little bit about optical illusions. Maybe I can show you kind of what I'm talking about here when I'm talking about this ambiguous cylinder. So let me just pull out my little box here. So if you guys could help me out on the chat, I want people to tell me, what shape do they see here? Let's see if anyone from the chat can tell me, what would you call this shape? Pretty simple shape, right? So what shape do you see? If I see anyone from the chat tell me what shape they see. Let's see. Okay. So what happens, what shape do you see when I turn this way? Is that the same shape or is it a different shape? Maybe you see more of a square. Let me turn it back. Oh, hey. Well, it's kind of more like a cylinder now. Okay, well, how is that possible? That's pretty wild. Well, let's see a couple other examples of this. Okay, what about this? What shape is this? Maybe a little bit of a funky cylinder, a couple cylinders, one one inside the other. Now what happens if I take it, turn that 180? Whoa, it is totally different. How did I do that? Is this magic? Absolutely not. But it is a really cool optical illusion. Okay, so you can get even more fancy with these things. So here, again, another kind of cylinder shape. What happens when I turn this one? Ooh, that one's a star. This one's a star too. Now watch what happens when I put a mirror behind it. This is when things get totally wild. Look at that. Yep, no tricks here. Same thing. How in the world is this possible? Well, I am going to show you how to design a very simple version of this, which is the first thing that I showed you. This guy here. We're going to design this in Solidworks. And then we're going to design, finally, this one, which I think is the coolest of all. What happens when I turn that around? How wild is that? Look at this. Okay. Put the mirror there. Totally wild. Really, really cool. So last thing I'll show you before we jump into SolidWorks and actually start designing is this is also based on the same kind of philosophy as the ambiguous cylinder. So we see an arrow, right? So we have right, left. So if someone could tell me in the chat, which direction is the arrow pointing? Is it towards the right or towards the left? Okay. All right. Well, what happens if I spin this 180 degrees? Then what happens? Wait, is it still pointing the same direction? That's wild. Well, look at that. No matter which way I turn it, it's always pointing to the left. Again, with my trusty mirror out here. What do you think about that? Even the mirror is deceiving your eyes. Look at that. Cool. So let's get into SolidWorks. Start playing and making this really cool ambiguous cylinder. All right. Here we go. All right, so in SolidWorks, so the first thing that we're going to do before we start designing anything, we're going to build, let's just call it a studio, right? We're going to build it, we're going to build a studio to create any type of these ambiguous cylinders, all based on some geometry, and you can use the studio to, yeah, like I said, build almost any of these and be creative and start creating some really wild ambiguous cylinders. There's kind of no rules for the types of shapes you can use to build these. So we're going to start by just opening up a simple new assembly, and I'll create an assembly in millimeters. Okay, good. And I'll start by okay. So I'll start by just creating some simple assembly sketches. And what this is going to do, it's going to kind of act a little bit like a master model or an assembly sketch that we're going to use to position some other parts that we're going to make from scratch. Cool, cool. So the first thing we want to do is I want to represent the floor, right? Because if I'm going to build a studio, I need a floor so I can place my little guy right on top of it. Okay, cool. So I use the S key all the time. And as you've noticed, many of the folks on these live streams have also used the S key quite a bit. So, so the S key is, like I said, it's one of my favorites. It's really just a palette that I can use at any time. And I'm going to start by just creating a standard center rectangle. There. This is on the top plane, no big deal. But I just wanted to make this for construction only. So when I select this for construction only, you'll notice that there's really no geometry here that I'm going to use for extrusions or any sorts of features. It's really just a visual representation of the floor. Cool. All right, so now we're going to create some other geometry on the front plane. So it might seem a little confusing what I'm doing at the beginning, but you'll soon kind of figure it out. So what we're going to do is we're going to say, okay, we have our floor plane here, right? And now we want to look, this illusion is all about the angle of sight at the top of this cylinder. It's all about the angle of sight, and it's all about the height it is off the floor. So we're going to build some sketches to give me an idea about kind of where I want this real interesting part of the ambiguous cylinder to take place, which is right at the top, and how far my eye is away from that, and at what angle my eye is away. That's the whole key to this entire thing. So the approximate height of this guy, we're just going to use this as a template. Got my trusty calipers here. We can see 67 millimeters. Okay, let's call it 70 just to make life easy. So again, my S key, I can pull a center line here. And I use mouse gestures quite a bit, especially for dimensioning. So, you know, if you hold in the right mouse key while moving the mouse, you can just kind of swipe up, and now I'm in the dimension key and dimension tool, and now I can just call this 70 millimeters. That's pretty easy. Okay, so we'll create another center line. Now, the extent of this center line is going to be where my eye is. My eye is at this point here, and I want to basically measure this angle and this distance. So my arm length, well, it's right around 500, it's about 500 millimeters, and I've got my trusty little measuring device here. Okay, so 500 millimeters, let's see, that's about right here. So 500 millimeters from my eye, right to the end, the top of this device. And we're going to look at 35 degrees. So 500 millimeters at 35 degrees is approximately where my eye is to the top of this, the top of the ambiguous cylinder. So again, I'll go back into my dimension tool. We're going to call this 500 or 50 centimeters. At an angle, and I'll say that angle from the floor, 35 degrees. Cool. So now I have the beginnings of my little studio I'm going to use to create. So let's move on and create another sketch on the right plane. Now this sketch is going to help me understand kind of the bounding box of this little part here. So the width, as you can see, can I see though? I see about 47. Let's call it 50 to make it easy. So 50 millimeters is the width of this part. So let's go ahead and create a 50 millimeter bounding box. Again, I'll use my center point rectangle. I'm going to align the center to that point where my height reaches my view angle. And I'll also align this rectangle right to the origin, just to make life a little easier for me. Turn construction on. I'm going to dimension this. We said 50 millimeters. All right. So now I'm getting real close to the point where I can start designing. So I forgot to do something because, as we know, the whole trick to this illusion is that you can see from one direction and the other direction look differently. So while I don't really want to spin my part around while I'm designing it, well, I should just create another view path going off at in the mirrored direction of this line of sight. So I'll go back and edit my second sketch, and I'll simply just mirror this entity, this line, and mirror it across my center line. Cool. Now that's easy. All right, we're getting close. We're getting close to actually starting to design something, but we're still kind of building our studio. So with these, I'm going to want to create some planes that are normal looking to these lines, these lines of sight that I've created. I'll want to make some planes there. And making planes, obviously, we know is super easy, but there's a lot of cool ways we can create planes. So if I want to put a plane right on the end here, and I want it to look directly down the axis of this line, well, all I have to choose is I can choose the construction line and the point. And it'll automatically slap a plane coincident or piercing right at the point I chose, and it's normal. It has a normal view right to the axial line that I chose. That's pretty nice. So I can create one plane, and now I create a second plane. Boom. Great. Now I have both of my planes that I need. Let me go ahead and turn plane view on. And now with those planes, just looking at the chat real quick. Oh boy, lots of activity on the chat. Cool. All right. So to make things look even fancier, we're going to bring in some components here so we can use to even help visualize more this little studio that we're creating. So again, using the S key, I can go ahead and insert some components. So I want to insert a little digital camera. And this digital camera is going to help me understand kind of where I'm looking and how I'm looking at the part that I'm about to design. So this is a cool little tip. So if I place this part anywhere here, well, I don't really know. If I want to place it close to the origin, well, that may look close to the origin from this view, but when I rotate, oh no, I'm so far away. Well, if I just go up here and click this little green check mark, it'll slap this guy right down, right at the center of my origin, so it doesn't get lost somewhere in the vast space of this assembly, which is pretty nice. Now, another thing that you probably know is that I can't move this as in place because it is the first part I have placed into an assembly. And you know that by this little F right next to where it says digital camera here, right next to the part. This little F means it's fixed in place. So if I right click the part, I can just choose to float it. And now I can move this anywhere I want and start mating this in place with, say, one of my planes. Okay, so the first thing I want to do is I want to mate the front lens element, that front face of the lens. I want to mate that to my plane. So I'll just click the front element. Doesn't seem like it wants to click. Well, why is that? I can't get that front face. Well, that's because the front element, that material, is made out of glass, which is transparent. And you'll notice in Solidworks, if you try to click a transparent surface, Solidworks wants to pick the first not transparent part, opaque part, behind it. It'll just kind of pass right over it. It's trying to click or pick that barrel on the inside of the lens. Now, if I hold the Shift key with my finger, hold Shift, you notice now when I hover over, now I get that front face of the lens, which is really nice. So I can click that, and now while holding Control, I can click this plane, and I get this really, really nice, what we call the Quick Mates toolbar. I don't have to open up my mate command. All the mates that SolidWorks could conceivably think of between this face and this plane, well, it says, well, which one of these possibly would you like to use? Well, I would like it to be coincident, sir. Thank you. So I'll go ahead and choose coincident, and now boom, this mate is now done. So a couple more mates to get everything all lined up. So I'm going to click. This time I don't want to use the Shift key because I actually want to select that barrel. So I'll select the barrel of the lens, holding the Control key, and now I can click my little axial line of sight. When I take my finger off the Control key, I get all of my choices in my quick mates. That's cool. So I want to make that concentric. Okay, so we almost have this guy fixed in place. So you can notice it can spin but right there on its axis. Let's go ahead and fix this completely in place. All right. So what I like to do is when I fix something in place, I often like to use some of the geometry of the assembly so everything is kind of in the same reference frame, the same coordinate system. That helps me. So I want to mate. Now, I'm going to choose the right plane of my digital camera. I'll hold the Control. I'm going to choose the front plane of my assembly. And I don't need this to be coincident. I just need it to be parallel. And now I have three mates. This thing is totally locked in place. And if I look down, say, the barrel of this lens, I'm going to look directly at the location of interest, which is going to be right here on my ambiguous cylinder. Pretty cool. All right. So I want to add another one of these lenses here as I'm creating my little kind of photo studio, ambiguous cylinder studio. So I could grab another one, drop it in. I could hold the Control key and just drag where it says digital camera. I could just drag another one in there and mate it all over again. Or I can do something even better. I can repurpose the mates that I created here. Well, I kind of want something the same but a little different when I place my next digital camera in here. So if I right click this part, I can choose copy with mates. Now, if you've never used this and you do a lot of assembly modeling, I urge you to figure this tool out. It can save a ridiculous amount of time. So much time, and hopefully I can prove to you right now and show you that. So I'm going to copy with mates. So first thing it says, well, do you want to use this digital camera component that I selected? Well, duh, yeah. Okay. Now, these are a representation of the 3 mates that I made earlier when I first put that component into my assembly. But what it's calling out for, it's saying, well, this first coincident mate, this is highlighted purple. It says you mated that front of that lens to this plane because it's purple. I can see that. Do you want your next one also connected to this plane, or do you want to choose some other surface to mate it to? Well, I'd like to mate it to plane 2. And now I finally get a representation of the part that I've copied, and it has one of the mates are now locked in place. Okay, what about that concentric mate? Well, it's purple is saying last time you mated that concentric mate, the barrel of the lens, you mated it to this line of sight, this construction line, which we're going to call it an axis right now. It's not really an axis, just construction line. Well, I will choose this construction line. Sweet. Now I have 2 of the 3. Lastly, well, I want to actually align the same plane on this, the new version on the copied, with the old. I want both of them to align to the front plane of the assembly. So if I hit the repeat key, well, it's just going to repeat that same exact mate. And cool, now we're totally placed in 3D space. But those of you who are a little bit observant, what's wrong with this picture? Yeah, this guy's upside down. I'm not going to take any upside down photos. Well, the reason it's upside down is because every plane has a top and a bottom. So it's aligning the same top and bottom that I used with the first component with the second component. And since it's rotated 180 degrees, it's going to flip upside down. This is a real easy thing to fix, but it gives me a great opportunity to show one of my favorite, more recent additions to the Solidworks user interface. This is a few years ago. So if I click on any face of any part in an assembly or even in a part editing, a part, you'll notice this has this new little kind of user interface up here. This is called Breadcrumbs. And what it really shows me is the entire history of how that part, or in this case, this face, came to be. What part is it part of? What features were used to create this face, et cetera, et cetera, et cetera. So if I click this face and I hit the D key, it brings this breadcrumbs right to my tip of my mouse, and it's saying, well, this piece is part of this 3D interconnect part, which is part of this solid body, which is part of this part, which is part of this assembly. That's pretty cool. Well, it also, when I hover over the part, it says, well, this part has 3 mates associated with it. Oh, well, that's cool. I remember putting those when I did the copy mates, and I know that this parallel one I want to change. So if I just simply left click that, I can now edit that feature. And all I want to do is I just want to flip the mate alignment. Boom. And done. So that's really all I had to do. Just flip that mate alignment. That was a big discussion, just flip mate alignments. But hopefully you guys saw a little something cool using breadcrumbs. All right, I'm going to hide these planes. Don't need those guys anymore. And I'd like to kind of shrink up my feature manager design tree. I don't really need to know all this information and all the history of these parts. So if I hit Shift C, cool little trick, Shift C, see it just buttons up my entire feature manager design tree, collapses everything. It's pretty nice. So let's finally start designing our cylinder. So I'm going to change the transparency of these. It's going to click these digital cameras, change the transparency. And now I want to create a new part in context. S key, again, instead of inserting a part, I want to create a new part. Cool. So you'll notice a little check mark next to my mouse cursor. That's saying, well, what do you want, where do you want to place this thing originally? What face do you want to associate this part to? Well, like I said earlier, I like all my parts to have the same orientation as my assembly. It makes it really easy to do in-context editing, I think. So it's calling out for where to place the front plane of the new part. Well, why don't I choose the front plane of the assembly? Kind of makes sense. And by default, it's going to create a sketch right there on the front plane of the part, which is also the front plane of the assembly. Don't really want to sketch there. So I'm going to go ahead and walk out of the sketch. Don't need it. But I am going to create a sketch after I change my part name. So I'm going to change this part. We're going to call this AC for Ambiguous Cylinder. And we're going to create this thing. I'm going to call it a squircle. It's like a square and a circle all at the same time. So a squircle. Squircle? Okay. And this is my Solidworks live design series. Cool. Go ahead and call it that. Sure, I'll rebuild and save. All right. So now let's start designing. So when I choose plane, I choose plane 1 and I want to create a new sketch aligned to plane 1, but this is going to be part of my new component. So when I zoom right down through the lens of this thing, what I really want to see, well, I want to see a circle, right? Well, it's not really a circle, is it? Because a circle looks like this. This is, if you look at a circle at an angle, well, what shape is that? Well, that's an ellipse. So I want to actually sketch what I'm going to see, which is an ellipse. So again, always using that S key. And I have my ellipse tool right here. I'll go ahead and grab my ellipse, align it to the top point, and I want it to reach the extents of my boundary box because I want this thing to be about 50 millimeters wide. Cool, cool. Choose that. Now, I'm a mechanical engineer by trade, and I like to put dimensions on everything. But part of designing this is we have to be a little more loosey-goosey with our design. I'm going to look at that and say, sure, that looks about right. And I'm just going to click it. I'm okay with blue sketches today. Blue sketches mean underdefined. I'm okay with that. All right, so I've created a sketch of what I would see from one vantage point. And now I'm just going to simply extrude that. Again, using my S key, I choose my extrude function. And this is just going to be a simple thin extrude. I want it to be 2 millimeters. Let's take a look at this. Nope, that's going the wrong way. I want it to go down. I want it to actually, the thin feature to be on the inside. Perfect. And all I'm trying to do here, again, no measurements. I just want to grab my arrow and I want to make sure that I'm extruding this right through that center, right through where this location is going to be, right at the top of my part. Cool. Finally have some geometry. It only took 29 minutes to get there. Sorry, everybody. All right. So let's continue on to the other side. So I want to create another sketch. And now I'm going to choose plane 2, which is associated with my second camera. So on one side, we see a circle. The other side, we see a square. Well, it's not really a square. That's kind of like a squashed diamond. Let's call it a squashed diamond. That's what I'm calling it. Okay. So again, using my S key, I have my rectangle tool. But how many of you, and I'll check the chat in a moment here, have you ever used the parallelogram tool? It's been in the software forever. We've always had this tool, but it is definitely an infrequently used sketching tool. But for this, it makes this really, really easy. So, parallelogram tool. I want to kind of align to the center a little bit, but I definitely want to have the edge of the sketch aligned to the extent of the previous extrusion, of that elliptical extrusion. So I want to make sure that that's aligned there. Align to the center line, sure. And then align on the other side as well. Easy. Also going to create some construction lines. Because sure, that might look nice and square, but I want to make sure that the two top lines are completely vertical and the two side lines are completely horizontal. So I'll create some construction lines here. Let's go ahead and just create a construction line there, a construction line there. And as Jordan showed you a couple weeks ago, you guys know that if you want to sketch lines and you don't want to have a tail on it, if you click, hold, and drag a line, when you deselect and you pick your finger up off the click, when you declick, unclick, what word am I looking for here? If you unclick, when you lift up your finger, it ends that sketch segment. So I don't have any tails. I don't hit the escape key or anything like that. Cool. So as I suspected, I wasn't completely horizontal with the sketch lines. Let's go ahead and make it horizontal. Nice. And let's do the same with this one, even though I'm pretty sure that one's vertical. And it is. All right. So back to our cylinder here. Yeah, it's more of or our diamond, it's more of a squashed diamond. Again, I'm okay with just kind of being a little loosey-goosey here. Sure, that looks fine to me. I'm okay with it. So let's go ahead and extrude this. S key, extrude, thin feature. Now this next part is really important, okay? I want to deselect merge result. Now, if you've never done multi-body design in Solidworks, there are so many cool things that you can do with bodies as opposed to multiple parts, multiple bodies. And that's going to be really essential for the next step of this design. So when you deselect merge results, that means, when merge results is checked, it means that any parts that come into contact with one another, that all becomes part of the same body. But we don't want that. I want these parts to intersect, but I still want them to be two completely separate bodies. Cool. Again, remember that I had 2 millimeters. That's great. I want to flip it on the inside, and I'll do something similar to what I did last time. I'm just going to kind of grab this little handle, if I can grab it. Can't grab it. Where are you, handle? There. There. Nope. It'll happen one of these days, I'm sure. There, I grabbed it. Okay. And I just want to extend it straight through so it just collides, fully interferes with my elliptical extrusion. Great. And remember, deselect merge result. Really important. All right. So what do I have here? I have 2 simple extrusions that are 2 separate bodies that are completely interfering right where I wanted to, right at the center, right at the top portion of where I want them to interfere. All right. So let's go ahead and kind of declutter some of our environment. I'm going to turn my digital cameras off. I don't really need them anymore. I definitely don't need my sketches anymore because I've already done so much of that already. And really, I just want to be left with these 2 simple extrusions. Now, the next thing I'm going to do is really cool. So there are, in 3D CAD, there are things called Boolean operations. And that's when you have multiple bodies and you can choose a bunch of different choices when you have multiple bodies of what to do when multiple bodies intersect or interfere or touch each other. There's cool things you can do. So our tool, it's called the Combine tool. And to be honest, I always forget where it is in SolidWorks. So again, I'm going to resort to my S key. Well, it's not on my S key, but if I hit S, well, that also opens up our command search. Just by hitting S, and I can just start typing immediately. I'm going to go ahead and start to type in Whoop. Don't see it there, and I don't know why. I have my 2 bodies. Why is my Combine tool not showing up? I'm sure someone out there is saying, you did something wrong, but I think I have 2 bodies here. Well, and I think that it's somewhere in my tools. Pretty sure. Make sure I selected 2 different bodies, and I sure did. See if it works this time. Nope. Didn't work. Try to rebuild. Oh boy. Okay. So let me just go ahead and find my, I have my features, combine. There it is. Why didn't it find it? I don't know. I had to find it myself. Okay. Well, sometimes you got to find things yourself, apparently. So what are the different choices I have for the combine tool? So we have the add, which means I'm adding together, which means that would mean both of these bodies, I want to turn them into one body. Don't want that here, but pretty cool for other applications. We have the subtract option, which means one part is like your main body, and the other part is like your subtraction tool, and you subtract one from the other. Very cool. Not today. Common. Now this is pretty slick. So when I select these two bodies and I hit OK, it's going to leave me with a very cool looking shape. Now this is the heart of the ambiguous cylinder, is right here. All the information I need right there. This is very, very cool. And this is all of the intersecting regions of that extruded diamond shape and the extruded ellipse shape. So things get cool when you start looking at different places. So I'm looking at plane 2, I see a pure diamond. If I'm looking at plane 1, oops. If I'm looking at plane 1, I see a pure ellipse. Do that one more time. Back to plane 2, normal to that. How cool is that? Very cool. So this in itself, honestly, I think this is 3D print worthy just right now. It's pretty slick. Something that's totally different from two different sides. Pretty nice. But now we're going to use this as a template to build the rest of this part. So the first thing I'll do is now I want to create a new sketch on the front plane. And I'll go ahead and create a sketch here. So this main line, this kind of S shape, well, if you notice on the actual part itself, you see that cut line, that S shape? This is the trick to the whole thing. Because now I'm going to kind of let the magician reveal its secrets. You can see this top profile. From this direction, this top profile is blocking the fact that it's a circle, so you see a square. On this section, this is a perfectly eclipsed edge that makes it finish out that circular shape. Pretty sweet. So I created a sketch on the front plane, and now I just want to convert a couple entities. That S shape is what I need here, this kind of wavy S shape. It's actually more like a flattened sinusoidal shape. Cool. So you can see I created a sketch that goes right down the center of the front plane. And this is pretty cool. You know, you can use convert entities, but you're not locked into the endpoints. I can stretch this out a little bit because I'm going to be using this to cut my part, and I want to make sure it fully extends past my part and doesn't get stuck on the end. So I can just grab the endpoints, push them out a little bit. And now it's for some very minor surface modeling. I want to extrude this surface, and I'm going to choose a mid-plane extrusion. And so I was under surfaces, extrude surface. Again, loosey-goosey today. I'm just going to make sure that my surface goes way past my part. That's all I need. Great. I'll hide that for now. Now I want to create a new sketch on the top plane. And I'm going to select all of the complete outer perimeter of this part. Now this becomes my extruded shape. See that? All the information is in that combine of the two different viewpoints. Pretty slick. So I'll go ahead and convert these entities. And it was very deliberate that I chose the top plane of not only the part, but also the assembly, because this is where I want to begin my extrusion. So real simply, S key again, we'll extrude. We really like this thin extrude at 2 millimeters. I want to make sure that it is on the inside of my sketch and definitely not to merge the result. Again, if I merged it, it would make that combined shape as well as this other extrusion. It's going to turn them into one body. I don't want to do that. I kind of want to divorce them from one another now. So again, I'm going to kind of just make sure I'm fully clear of my sketch and my surface. Okay. And now let's bring my surface back into view. I'll hide my combined body. And now another very simple surfacing feature, cut with surface. It does exactly what it describes. It cuts a body with another surface. That becomes my cutting tool. Pretty easy. So I'll choose my surface and I'll choose my body. And it's saying, well, you want to cut everything below the surface or everything above? That's it. That's all I have to choose. So, well, I want to cut above the surface, please. And I've cut it. And now when I take away my surface, look at that. You know, I've been playing with these things for years, and it still just blows my mind every time I do this. It looks so cool. And like I mentioned, if you have kids, you will blow their minds with these things. And if you have a 3D printer, that's even cooler. Or if you have access to a 3D printer, these things are made to be 3D printed and in your hands. And when people come over, or when we have people over next, they're really fun to bring out when there's kids around and just to trip people out. People think they're seeing something that's absolutely magical. So I think this is pretty cool. So let's move on. I'm 42 minutes after the hour. I don't want to take too much of your time. Oh, here we go. Someone, Gnome, asked, why not extrude up to the surface? You could totally do that. You could totally do that. I just would have had to do my operations in a little bit different order. Created the surface, then created the sketch, and then extrude up to surface. Totally could do that. It would save, Xiaodun Lin says it would save one feature. It's true, it would. I wouldn't have to use the cut with surface, but I kind of wanted to show cut with surface because I like that tool. Eric Beatty says it's witchcraft. I promise you, I'm not a witch. And the curve, yeah, the curve is really cool. All right, I love the chat. So let's get even further. Let's build this thing. Again, let me show it again. Pretty cool. Circles, diamonds. Yeah, pretty slick. So let's show this. So I'm just going to hold the control key and I'm going to drag out just another one of these parts that I just designed. Now, the first thing I want to do is I want to fix my original one in place. I'm going to fix it. I don't want to move around. I only want to be able to move around the one that I brought in. Because as you can see, this is just simply an array of 5 of this exact same shape. All right, I'm just going to control click these 2 faces and use my Quick Mates toolbar like I used before. I want them to be coplanar. So now is when things get, like before, get a little bit more loosey-goosey. Well, I know I kind of want these points, if there's an imaginary line between these 2 vertices, if I could visualize the midpoint there, I want that midpoint to line up with the midpoint of this edge. That's what I want to do. So I'm just going to kind of drag it. Again, not how I'm used to doing things. I'm used to doing things that are fully mated in relations and sketches, but this is fun. Remember, we're doing something fun and cool, so we want to make sure that it looks as good as possible. I could take the time and dimension this whole thing out, but nah, not today. I just want to have fun, and I'm just going to try and place this as close to there as possible. Okay, cool. So now I just need a few more of these, and this is a perfect situation to create a component pattern. Well, luckily for me, I have a sketch that's going to have a perfect axis for what I want to do here. Okay, I have this original sketch from my studio. This is going to play a great axis because I'm going to do a circular component, right? I mean, a circular array. I want 3 more of these things right around the dead center. This is going to be perfect. So I want that direction to be wrapped around this little axial. We're going to call this an axis, but it's really just a construction line. Well, I know I want 4 of them. And what do I want to component? Well, I want to pattern this component. Perfect, not 5, 4. And I want them to be spaced equally. Perfect on, uh-oh. Well, that doesn't look right. Oh yeah, that's right. A circular pattern rotates each instance around itself. That's not what I want. Darn it. I want a linear pattern. Cool, cool. So let's kind of unwind what I just did. I'll turn the sketch off. Turns out I don't really need anything at all like that. And create a linear component pattern. And based on my directions, well, I'm just going to use some of the planes, some of the native planes from my assembly. Okay, I want to use the front plane for one direction. I will use the right plane for another. I know I want 2 in each direction. That's pretty simple. And what component I want to pattern? I want to pattern this one. Okay. So I want to kind of tap this thing into place, and I want these 2 points to perfectly eclipse these 2 points of this part. I want to just perfectly, just kind of go right over itself. So if I kind of move this around, I can kind of get close. Well, all right. Well, it looks like it's stuck at 10 millimeters. Boy, that's some really coarse adjustment, isn't it? Well, maybe I find, well, it's like 40, maybe it's more like 42 and a half. I could start punching in different numbers to try to get that value perfect. Or what I can do is I can change what we call our spin box increments. Because I just want to lightly tap this thing into place. So in our options, now I use this all the time because obviously earlier when I was looking for the combine tool, I honestly didn't know where it was. I kind of had to fiddle around and find it. I am not good at remembering where everything is. So I like searching for stuff. And using our system option search is very easy for me. So I know it's called spin box increment. Spin, oh, that's first one that comes up. Spin box increments. And right now, my metric units are set for 10 millimeters at a time when I hit that up and down arrow. How about 1/10 of a millimeter? Now that's real fine adjustment. I like that. So I'll go back to my component pattern, edit my component pattern, and now I can just start tapping this thing into place. Perfect. That is great. Just gonna kind of tap it in here. Remember, we're having fun, so it doesn't have to be perfect. I just want it to look right. All right, and we'll do the same on the other one. This one, I'll just kind of tap it into place here. 1/10 of a millimeter at a time, takes a little longer, but I can have real precise movement and just line it up perfectly. You know how long it would have taken me to figure out that it was 47.8 millimeters away? I don't want to take that time. I'd rather just tap it into place. All right. So now I have my pattern. Look at that. Again, if you guys haven't noticed, I'm using rotate about floor, which is my rotating tool. It's really nice for the ambiguous cylinder. When I rotate, look at that. So cool. I still think it's cool after all these years of playing with these things. I love it. All right. So what would be the next thing? Well, you could 3D print it. You could show it to a friend. You can have someone come over and use e-drawing. You can send this as an e-drawings to someone, so someone could open it up on any computer and view it, which is pretty sweet. But what if we wanted to 3D print it and wanted to get an idea about kind of where it would fit in our build space and kind of what the striation lines would look like when we print it? Well, Solidworks has some 3D printing capabilities built right in, so we can kind of do a lot of the visualization process of KCB, thanks for that comment. I love Sesame Street, so I take that as a compliment. Okay, all right, so let's get into 3D printing. All right, print 3D, cool. So a lot of printers are already built in, like my printer, my little kind of home 3D printer, my Sindo 3D Walks, well, it's here too. So I can kind of choose, I manage my favorites. I know that it comes from Sindo, which is right here, and I have the DP200. I'll just go ahead and add that to favorites. And when I choose it, well, all of the information, the width, depth, height, all of my build space, all of that just flows right in to the 3D printing environment here. I can open this up a little bit so we can see more of what we're doing. Cool. So now it's going to ask me, well, what's the bottom plane? I like my top plane to be my top plane or my bottom plane, so perfect. And now I have my build space. This is great. I can offset, I can push it one way or the other. I can either use my spin box, or I can go ahead and just say, well, I want this 10 millimeters that way, please. I can change the scale. This thing might be kind of big. There's a lot of material. Let's say I want it to be half its size. Cool, nice little guy. I can change the quality. I can change the percentage of infill. You know, when you have a thick part that you're printing, kind of like this, I don't want to fill this whole thing with print material. That's kind of a waste. I want it to be just a real simple crosshatch inside. I don't want to waste my material. And now I can get a good preview. Now, if I want to see faces that require support, I can also run in a little analysis there. Now, since we're talking about something that is made to be 3D printed, there is zero overhang region. This is great. But what if I was not thinking straight and I said, well, nope, I want to print this like this, darn it. That's how I want to print it for some weird, wacky reason. My preview is going to help me understand where I'm going to need to put in, as you can see here, where support material will be required. And I'm kind of at an off angle here because I have my rotate about seam floor. But this will give me an idea about where I want my support material to go. And I can even change this value that basically is intrinsic to most printers that said, well, if you have an overhang region that's more than 30 degrees, you're going to need support. Less than that, we can handle it. It's a pretty nice little tool here. All right. So I will definitely be sharing this part with everybody. I'll just button it up and share it. I'd love to see if you guys actually print it or play with it or think it's pretty cool. I'd love to see that. And that's most of what I wanted to show today. We are 52 minutes past the hour. So one thing I want to show real quick is that I designed, sometimes I have to rotate it just to see what I'm actually looking at here. So I designed this one from scratch, and I figured that it'd be cool if I just show you kind of the process I went through. Now this one was a little bit more complicated. I had to use a 3D sketch, and I had to use a 3D sketch, and I had to use a different surfacing tool to kind of capture this edge. Now, if you look down the side of it, you'll see this is not a perfect, it would be impossible to create a plane that actually cut this thing in one shot. I had to create a surface using a fill surface. So why don't I just open that up real quick, and we can play around with that for a minute. And then I have one really quick thing to show you at the end before I conclude. So let me open up, what did I call it? A starkle. It's a star and a circle, a starkle. So here we go. Here's this one. That's a 5-pointed star and a circle, pretty cool. So you'll notice that what I had to do after creating the combined surface, which we all understand what that is now because we've talked about it so much. Creating this surface, I needed to pick a very complicated set of edges here and create this 3D surface, which I'll show now and kind of hide all this stuff. So I had to create this 3D surface and use a surface fill, which did an awesome job at actually interpolating a 3D surface. Oops. Sorry. You guys can't see what I'm doing, and I apologize. I had the wrong screen on. So sorry. I should have been looking at the, thanks for, I know, I love this shirt too. Thanks, I appreciate it. Monitor! So let me actually just redo what I just showed. Okay, here we have our star, our squircle, circle, star, pretty cool stuff. I'm just getting new at the OBS software, so I forgot to go back to my other setting. So let's talk about this 3D sketch. And this is the 3D sketch I created, which is based around this combine. I had to kind of pick through a lot of these edges and find this 3D surface and then use, and I'll turn this on and hide this, to create this really nice, beautiful fill surface that was interpolated from the choices I made in this 3D sketch. And that was the only thing really different here. I did the same extrude, I did the same cut with surface option, and I could try and include this also in the tech pack that we can send out to you guys. All right. So The last thing I'll share with you, and then maybe I could answer some stuff on the chat here. And now I'm deliberately going back to my webcam. I promise you, I'm deliberately doing this. So if you don't have, say you don't even have a computer and you want to create something cool that with stuff that's in your house, this one's pretty cool. So I'm sure a lot of us have a lot of these sitting around the house these days. Well, I hope you do, because that means you had some. But looks like maybe my screen froze. Sure did. Oh, it's back. Okay. All right. So I'm sure you guys have some of these sitting around, just a standard toilet paper or paper towel roll. Now watch this. This is pretty cool. So I have trusty scissors here. So I'm going to make two very simple cuts. One, I want to make sure you can see where I'm cutting. Just a cut about, I'd say 1 centimeter in. And then on the other side, we'll do the same thing. Another cut about 1 centimeter in. Cool. You can see I have two cuts. Very simple. Now from the top, I'm going to make a cut. I'm going to cut that. I'm going to rotate down to the base of this cut. Again, pretty simple here. Cut, 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 cut. Get rid of that. And I'm going to do the same on the other side, right here. There. So we should end up with something kind of like this. So watch this. So if I take this and kind of squash it a little bit like, again, back to my ellipse again. Does anyone in the chat, does anybody see an arrow? And if they do, is it pointing any direction? This way or that way? Well, I hope that everyone sees it pointing this way. Now watch what happens when I rotate this. Hey, look at that. It's still pointing that way because I see a different side. So in 30 seconds, if that, find my mirror, here it is. In 30 seconds, I created a very, that's going to be tough, a very simple optical illusion just with scissors and a toilet paper roll. That's it. Pretty neat, huh? Look at that. So simple. And you guys can do it at home. Stoke your kids. Well, let's take a look at some of these chats. All right. Well, thanks. I love, I see Andrew Bonica here. Fantastic. I think I know that guy. Jordan, thanks for joining. Your session on creating stairs was so awesome. I'm glad that I'm in the same family as some of these other masters. Okay. Well, I think that is going to conclude my session today. I was able to get through just about everything I wanted to show you in right about an hour. If anybody has any questions on the chat, maybe I can keep it open for another minute or two and take a look. Well, you're very welcome, Mustafa. Thank you very much for joining. I appreciate it. Okay, well, maybe we'll go ahead and conclude now. So thank you all for joining. Stick around on this channel. If you like this, like it. If you really like it, I want you to subscribe. Subscribe to our channel. We have lots of rad stuff, really, really cool stuff. Like I said, this is the 11th of these live design series. The 10 before mine were amazing. So please, if you haven't seen them all, check them all out. They're all really great and presented by some of the best presenters and things I've learned the most in my entire life. Next week, on May 29th, Steve Fick, my colleague who is in South Bend, Indiana, he will be presenting on how to create a DIY planter box. And it's pretty cool. We all love growing vegetables. I have a place for vegetables in the back as well. I'm going to watch it and probably build exactly what he's showing me because Steve is the man. So with that, I'd like to say thank you and have a wonderful weekend, an excellent day, and hopefully I have the opportunity again to present to you again. So thank you all and have a great weekend.